It is finally time to do the very last lesson in this module, Chapter 4 or Module 4, Lesson 6, Compute with Scientific Notation. Lesson goal says students will compute numbers in scientific notation, and the suggested pacing says this is going to be a one-day lesson, which I hope it is, because I've been working on these for hours on my Sunday afternoon, and I really want to be done with it. Lake Superior is one of the Great Lakes of North America, and it is the largest freshwater lake in the world. The volume of the lake is approximately 1.22 times 10 to the fourth power. 10 to the fourth power cubic kilometers. This is enough water to flood all of North and South America to a depth of 1 foot. Think about that. To cover the entire continental space of North America and South America combined, 1 foot deep. That's how much water is contained in Lake Superior. Meanwhile, the Pacific Ocean is the world's largest ocean. It has an approximate volume of 6.6 times 10 to the 8th cubic kilometers. The volume of the Pacific Ocean is more than double the volume of the Atlantic Ocean. From here, we can take and say, they gave us a volume of Lake Superior and the volume of the Pacific Ocean, and they say, how can you determine about how many times larger Lake Superior is than the, how much larger the Pacific Ocean is than Lake Superior. These are the kind of things we're going to learn about in this lesson. To solve real-world problems involving numbers written in scientific notation, you may need to multiply or divide these numbers. Since numbers written in scientific notation contain exponents, sometimes the laws of exponents can be used when operating with them. With all operations, it is helpful to write the numbers in the same form, scientific notation or standard form, before computing them. When performing these operations with numbers written in scientific notation, remember to, well, if you're doing multiplication, use the product of powers property, and if you're doing division, use the quotient of powers property. Here's some creepy statistics for you. Scientists estimate that there are over 3.5 times 10 to the 6th ants per acre in the Amazon forest. If the Amazon rainforest covers approximately 1 billion acres, find the total number of ants written in scientific notation. And how will you set this multiplication problem up to solve it? Well, we either have to convert the scientific notation into standard form, or we have to convert the 1 billion standard form into scientific notation. Since this lesson is all about scientific notation, we have to take and go ahead and convert the 1 billion into that. So let's take and go over here to our scratch slides, and we're going to go ahead and work on that. First thing I'm going to do is going to write 1 billion. So 1 billion is going to be 1 with 9 zeros after that, because 6 zeros is million, 9 zeros is going to be billion. From there, convert that to scientific notation. 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's going to be 1 times 10 to the 9th power is what that would be in scientific notation. We'll come back over here, type that in. 1 times 10 to the 9th power, accept and check, and that part of our problem checked. Next, we're going to move through the following steps to multiply two numbers that are written in scientific notation. Now, it looks pretty intimidating, but it really isn't, because we know the commutative property of multiplication says order doesn't matter when multiplying, and the associative property of multiplication says grouping doesn't matter when multiplying. So these two problems here, the number of ants per acre times the number of acres, we can take and rearrange that. I have the constants here of 3.5 and 1 that I pulled out, and I have my exponential numbers of 10 to the 6th and 10 to the 9th. From there, we could take and rewrite that as 3.5, because 3.5 times 1 is 3.5, and I would have gone ahead and done this next step too. That would be 10 to the 6 plus 9, which they did right here, and then 10 to the 6 plus 9, that's going to end up being 10 to the 15th power. Multiply 3.5 times that, and then you say that, so the total number of ants in the rainforest is going to be approximately, well, I don't know, do they want that in standard form or scientific notation? I'm going to say scientific notation, which is 3.5 times, where it is, 10 to the 15th power. Hit accept and hit check, and it checks. How many ants is that though? I just got to know. So we're going to come back over here. I'm going to take my number. Let's do this. I'm going to take, I'm curious here now, 3.5 times 10 to the 15th. So y'all work it with me here. I'm going to start with 3.5, and then we're going to count out 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Stick a whole bunch of zeros in here. And I don't even know if I'm going to be able to tell you what the answer to this is. Put in our commas where they belong. So let's go ahead and rewrite this. It's 3, 5, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, and 1, 2. I think I got that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Yep. Put my commas in where they go. So if we were to work this out, this is thousands, millions, billions. Oops, I missed a zero. That comma actually goes there. So let me replace a couple of those, put them where they belong, here and here. So let's say thousands, millions, billions, trillions. What comes after trillions, Bennett? What comes after trillions?
Quadrillion.
Okay, he guessed quadrillion. I don't think he's real confident in that answer.
Quadrillion.
It is quadrillion? Okay, so 3 point...
Something like that.
Okay, he doesn't know either. Makes me feel better. So let's pretend it's quadrillion. 3.5 quadrillion ants in the African rainforest. That's an awful lot of ants. Now it's going to be your turn. The speed of light is about 1.9 times 10 to the 5th, and it takes 500 seconds for light to travel to the sun. So, which one of those is going to be the appropriate answer? They gave you a hint. They want it in scientific notation, even though it really doesn't make a whole lot of sense. But we shall see. First thing we need to do, of course, is take that 500 right here and convert that to scientific notation, and that's going to be super easy. 1, 2, that equals to 5 times 10 squared. And then we can say from there to find out what the distance is going to be. We're going to take the 1.9 times 10 to the 5th, multiply it times 5 times 10 squared. Rearrange using our commutative and associative properties. 1.9 times 5, and technically there's no reason to use parentheses on these, times 10 to the 5th times 10 squared, although it may make you feel better to use them. From there we're going to multiply. Let's see, that's going to be 5 plus 4.5, so that would end up being, I think I'm right when I'm going to say 9.5, but let's find out. Yep, I'm right. 9.5 is going to be what you get when you multiply that times 10 to the 5th plus 2. So your final answer, 9.5 times 10 to the 7th. Come back over to our answer key, and that is going to end up being, boop, answer C. Check your answer, and the answer checks. Easy math. But what if we wanted to divide scientific notation? How is that going to work? Neurons are cells in the nervous system that process and transmit information. An average neuron is 5 times 10 to the negative 6 meters in diameter. A standard table tennis ball is 0.4 meters, also known as 4/100ths of a meter in diameter. How many times greater in diameter is the diameter of the tennis ball than that of the neuron? To find that out, we're going to have to take the tennis ball's diameter in scientific notation and divide it by the size of the neuron in scientific notation. First thing that means is we have to take and write the tennis ball in standard forms. We're going to bounce that decimal 1, 2 spaces to the right. So that means we're going to have 4 times, times 10 exponent, and that's going to be a -2 because we're going from a number less than 1. Check your answer, and that part checks. So we have the scientific notation of the size of the tennis ball. From there, we're going to take and set up our division problem where we have the tennis ball divided by the neuron. Move through your slides here, and they've broken it down as the 4 divided by 5 times the 10 to the -2 divided by 10 to the -6. 4 divided by 5 is 0.8, and I would also go ahead in that same step, and I would have done times 10 to the -2 minus a -6, because remember, when you're dividing, the quotient of powers property says when you divide exponents, you subtract them. Of course, right here you have a negative times a negative, which is a positive, so you have -2 plus 6, which is going to equal to 10 to the +4. So the answer to that question in scientific notation, the textbook, or excuse me, actually, that's not really quite the answer, because they said to put it in scientific notation, but it's not. The decimal's in the wrong place. So they stopped at that point where they said that the tennis ball is 8 times 10 to the 4th larger than the neuron, but there is going to be an issue there. We need to change that to scientific notation, so that means we're going to bounce the decimal 1 space to the right, which means that from there it would actually be 8 times 10 to the 3rd larger, also known as, well, if we bounce that decimal 3 times, that would be, I believe, if my math in my head is right, 8,000 times larger than the diameter of the neuron. That's pretty significant. Now it's going to be your turn to solve this problem that says the largest planet in our solar system is Jupiter with a diameter of 143,000 kilometers. The smallest is Mercury with a diameter of 5 times 10 to the 3rd, and they want you to find out how many times greater the diameter of Jupiter is than Mercury. Go ahead and pause the video and work on this one. First thing I'm going to do when I solve it is I'm going to take the diameter of Jupiter, change in scientific notation, 1, 2, 3, 4, 5. So that's going to be 1.43 times 10 to the 5th. That's going to be the diameter of Jupiter. Now we're comparing Jupiter to Mercury, so I'm going to put Jupiter size, 1.43 times 10 to the 5th will go on top. Mercury, 5 times 10 to the 3rd is going to go on the bottom. From there, we're going to break down the pieces parts, which means I'm going to have 1.43 divided by 5 times 10 to the 5th divided by 10 to the 3rd. I'm going to use my handy dandy pocket calculator on that little calculation. 1.43 divided by 5 is equal to 0.286 times 10 to the 5th minus 3. That means from there 0.286 times 10 squared, which means that from there we could take and estimate that as being about 28.6 times bigger, because they gave us some choices here for whole numbers to choose from. So which one's going to be closer? I said 28.6. That's closer to 29, and 29 is indeed going to be the answer. Now I should give you a little more detail about what happened here, because it was times 10 to the 2. That could be rewritten as 0.286 times 10 squared is equal to 100, and anytime you multiply something by 100, all you have to do is move that decimal 2 spaces to the right. This looks like a good place to end this video. When we come back, we're going to talk about adding and subtracting with scientific notation, which should be a pretty interesting thing to learn. We'll see you in part 2 in just a few minutes.